everyone. I'm Jasmine, and we're four students here at RIT for our NorthStar program. Khalid's holding the camera. This is Khalid and Blair, and this is our professor, Jake.
And we're just going to show you a little bit of our project, like what it's based on. You go in this room. Let's go. All right, this is the cube, right? And what it does is it has a 3D image on the inside. If you go inside, it looks like you're surrounded by a carbon nanotube, which is what we've been working on for the past 3 weeks. Now, what a carbon nanotube basically is, it's a very small object. It can be used potentially for a lot of applications. Batteries, it can be used for armor and armed forces, things like that. But we're just like doing the research. We just want to give you a little background information.
We're here in a different room, and we're going to show you a PowerPoint that we made to let you guys know what carbon nanotubes are about.
Okay, so what you're looking at is a carbon nanotube. You can see how it's circular shape, which is also called chiral, but we'll get into that later. It's made up of these little hexagons. I don't know if you can see it in the video, but it's made up of these little hexagons which affect the conductivity and the resistance of it, as you'll learn later. So the last line you saw, this is bond again because of a special point that we change up called the van der Waals force. And I'll pass it off to Kool-Aid so you can explain point.
Alright, so here you see some size for the carbon nanotube, just so you gain some perspective. It's very small, 0.36 nanoscale, nanometers for this nanotube. And for this piece, it's about 0.2 to 0.5 micrometers long. This is so that you can tell how small this structure really is. Alright, so here we have the different types of carbon nanotubes. We have the zigzag nanotube, the armchair nanotube, and the chiral nanotube. And each different type has different properties. So one might have better conductivity than the other. They have two types of characteristics depending on the type of nanotube you have. It can either be metallic or semiconductive. And all those properties are determined by the chiral vector and the chiral angle. And here's how we tell. Imagine a graphene sheet rolled up in a tube, and that's basically what a carbon nanotube is. So if you roll from one end to the other, you get a zigzag nanotube, and at a 0-degree angle. And if you roll from a 30-degree angle down the diagonal of the sheet, you get an armchair nanotube. And N, the first in this letter arrangement, N is just how many arrangements of carbon you have, and 0 is so 0 is the M, and when you have a zigzag nanotube, it's the number, and then M will always be 0. And when you go down for an armchair nanotube, it's N equals M, so you get 0, 0, 1, 1, 2, 2, 3, 3. And chiral is just any arrangement in between the two nanotubes. And here you can see a different view of each of the nanotubes. An armchair is called an armchair because when you sit down on an armchair, the hands rest in a certain position. So, and then in the zigzag, it's pretty obvious. You get a zigzag pattern. Chiral is just anything in between, so it could be basically it's like an armchair, but twisted. And then Blair will explain the rest for future applications.
About the potential application for nanotubes. Because of their unique characteristics, nanotubes are
very useful for many applications.
They are really strong. They have a high thermal and electrical conductivity. They have a high surface area. They are corrosion resistant. They are durable, flexible. So they are coming using batteries, wires, transistors,
even makes sense.
They have used them for like textiles, like waterproof clothes and armor. We also have been using some concrete and steel to make it stronger. It's like the strongest material known right now. And currently, RIT scientists are working with plastic material and nanotubes to make solar cells. And they have like a really potential, but scientists are like facing a lot of problems with them in their production because
it's not really that efficient to make them. Basically, all you do is burn carbon, and the result is soup, and so carbon nanotubes are really efficient. So until they can make a better way of making them,
they're
probably not.
they're very expensive right now. So right now people are talking about like using them to replace copper, steel, and basically
But to know, like, all these applications, they're just tested applications. They're not like, completely,
they're not into the public.
these tested future applications that we want to get into.
Nanotubes have been used to memories, like in your computers and all technology. So we hope that with this presentation, more students become interested on this topic.